Hello student, today we are going to discuss here how we find the equivalent resistance within a cube and its is having the equal resistance, each is having equal resistance. So we have to find here the equivalent resistance across the face diagonal, body diagonal and its is. So let us start here with the body diagonal. Here the current I is showing. So in this scenario, the body diagonal is AH. AH is here body diagonal. So we have to find the equivalent resistance across A and H. So let us consider a battery source here. So I current flowing in this circuit. So this current distributed I by 3, I by 3 and I by 3 because of the resistance is same here. So further in this branch, the current further divided by I by 6, I by 6 and here I by 6, I by 3 further divided here I by 6, I by 6. So here the current would be I by 3 and here would be I by 3 and here would be I by 3. So in this scenario, we have to find the potential at this point and this point. So we see here the potential at B, E and C would be the same because of from let a battery is connected here. So let the potential of A is V and potential at that point, that is H, is 0. So while going on direction of current, the resistance across the resistance, the potential is drop. So here the potential would be V minus I by 3 into resistance and here would be the same and here would be the same. So C, E and B are the point of equipotential. So these are equipotential point and similarly the potential at G, D and F are also equal because of from moving here to here, this current is I by 3, this current is I by 3. So the voltage would be voltage would be this point and this point and this point would be the same. So and if we cut this plane along the diagonal, so this plane on cutting the diagonal, so this are lies on a same equipotential region and similarly these points C, E and B lies on the same equipotential surface. So we have to find the equivalent resistance between A and H. So this is the A, this is the H. So resistance C, E and B equipotential points C, E and B. And similarly G, D and F. G, D and F. G, D and F are equipotential point. So we write resistor A and C in between A and C one resistor, A and E one resistor, A and E one resistor. Three are parallel. These resistors are parallel. So we draw here one resistor, and one resistor. Three resistors are parallel. And C point C is connected with D and also G. So 2 points, each point connected with corresponding 2 points. So here we draw the resistance, this resistance, 6 resistance here. For for a single point, 2 points are connected in parallel. So this becomes and this becomes. These are in parallel. And similarly, these three are in parallel. So we draw here. So this is the resistance of RAH across this diagonal, body diagonal. So this becomes R by 3, R in parallel. So this becomes R by 3, R 6 resistor here. So this becomes R by 6 in parallel. So this becomes R by 3. So finally we get 6 2R, 2R, 4R and 5R. So this becomes R, yes, this is across the body diagonal. So R equivalent would be 5R by 6. And similarly, we can calculate out here for the capacitor, the capacitance, equivalent capacitance. So for the capacitor, suppose here the 6Q charge is from battery, 6Q charge is driven in the system and minus 6Q charge is releasing from the system. So 6Q charge is divided in 2Q, 2Q, 2Q because of capacitance of each capacitor is C is given here. So 2Q charge is here, so positive 2Q and minus 2Q, and this charge is here further divided. So charge on this plate would be Q minus Q, and here this charge and this charge divided charge, this becomes 2Q minus 2Q. So here the charge on the capacitor plate. So we choose the root A, B, H. So in this path we applied the voltage, summation of voltage that would be V, total voltage. So summation of voltage V is equal to 6Q upon minus upon C equivalent. 6Q, let me suppose the charge initially condition when the charge is flown in the circuit, and this is the charge leaving the circuit. So V1 plus V2 plus V3 becomes V is equal to Q upon R. So this becomes minus 2Q upon C. So this becomes Q upon C, and this becomes 2Q upon C. Here 2Q upon C is a 2Q upon Q. Here the charge is Q, so becomes Q upon C potential. Here potential is minus 2Q upon C. Here Q minus Q upon C. Here minus 2Q upon C. So this becomes 5Q upon C is equal to minus 6Q upon C E. So CE becomes 6C by 5. This is the equivalent capacitance. And further we have to investigate phase diagonal, along the phase diagonal, equivalent resistance along the phase diagonal. So in this scenario we have cut the phase diagonally, we have cut it phase diagonally. So we find the symmetry when we cut it in at phase diagonally. This is the phase diagonal, this is also phase diagonal, like as this also the phase diagonal, this also phase diagonal. So we have to find the equivalent resistance along the phase diagonal, this condition. So we have cut this section. So we on cutting this we finding the potential here and potential here. This is the point we have to find the equivalent resistance along this phase. Suppose I current is flowing and I current is emerging here. So this current is flowing, entering, and this current is leaving. So in this scenario we cut the diagonally. So on cutting the diagonally we find this is the this and this, and this point and this point. Similarly, this point and this point would be having the equipotential. So here G point. So we write we have to find the equivalent resistance across D and H. Similarly, this parallel diagonal will be A and F. This is the parallel diagonal, and this here and here, this point. This is in between the D and H, so G and F. G and F would be the same potential. By cutting this diagonally, face diagonally, so this shows G and F have the same potential, and similarly D and B also same potential, D and B. So right here here the one resistor is here and two resistor is here. These are parallel, and similarly here two resistor, and here two resistor, here two resistor, here two resistor. These are parallel resistor, and here and the here here here. So the scenario is like this. So here in this position B and D, this point B and D, B and D, B and D. This is not B and D, A, yes, right. B and D. B and D has same potential and G and F also same potential. When we cut the its diagonally, when G and F having the same potential diagonally and this point also diagonally. So these points also the same potential. So we find the equivalent resistance here. So this is point A. So R, this is R, this is also R, and all resistors are equal. So between A and B, the resistance will be R by 2, and this is suppose D point or B point. So this resistance would be R by 2, and this resistance would be R, this resistance would be R, this resistance would be R, and this resistance would be R by 2, and this resistance would be R by 2. This is D, this is F, G, and this resistance would be R by 2. So here we have to find the equivalent resistance between D and H. So here R by 2 and R. R by 2 and R is in series. So this becomes 3R by 2, and we can draw it like this. This is 3R by 2, this is R, and this is also 3R by 2, 3R by 2. R by 2 current flow on moving the current. So this is in series R by 2 and R. So because this becomes 3R by 2, this becomes 3R by 2, and this is R by 2, and this is R by 2, and this is also R by 2. This is also R by 2, and this is the point D, and this is the point H. So we have to find the resistance between D and H. So this 3R by 2 upon R by 2, 3R by 2 upon R, this is Wallace Wheatstone bridge, so no current flow in this branch. So we can solve it. These are in series and these are also in series. So equivalent would be, this would be 3R, 3R by 2, 3R by 2 becomes 3R, or this would be R. So this is D, this is H. So we have to find the equivalent resistance would be R equivalent would be 3R cross R upon 3R plus R. This becomes 3R by 4. This is the equivalent resistance for the phase diagonal. And we have to calculate here the equivalent resistance across the edge diagonal. Edge, not diagonal. So select any edge. We have to calculate here. So suppose AB is the edge. So here we remove it and we find the equivalent resistance through its edge. So this becomes, the resistance is here. So this is the I current, and this flow here I current. Battery is connected here. So we have to find the, so we apply here folding symmetry like as, like this. So when we press this face, so what happened on pressing this face, what happened? So this point coincide with E. D would be coincide with E, and C would be coincide with C. F. C would be coincide with, on folding symmetry, the coinciding point would be the same potential difference. On folding symmetry, the coinciding point having the same potential difference. So we have to calculate here the potential difference across A and B. This is the AB. A resistor is here, and similarly this is the front side of the GH. So write here GH, and due to during the folding symmetry, this point lies here and this point lies here. C lies here, so D lies at E, and C lies at F. This is the position. So we have draw here the resistance. So A is connected with D and E. So he is also connected D and E. So two resistor here. This is one resistor. This is suppose one, and this is second. So this scenario, and similarly D and C connected. So D and C, and E and F connected. So this is parallel again. C connected with B, C connected with B, F connected with B, F connected with B. So both are connected here like as. So this, and G connected with D as well as E. So this becomes like this, and similarly like this. So this is the circuit here. So we have to dissolve it and get the equivalent resistance across the AB. So this is RR parallel, so this becomes R by 2, this also becomes R by 2, this is R by 2, this is R by 2, this is R by 2, and this is R. So here these three are in series, R by 2, R by 2, and R. This becomes 2R. So 2R, and this is R by 2. This and this becomes R by 2. This and this becomes R by 2. So here 2R, here 2R by, here R by 2. Here R by 2. Resistance is R by 2. Here R by 2. We have right here equivalent resistance. This resistance is R, this resistance R is equivalent to R by 2. So here R by 2, and here also R by 2, and here is R. This is R. So this is A and this is B. We have to find the equivalent resistance across A and B. So solve this. R2R and R by 2. The equivalent resistance of 2R and R by 2 would be 2R plus R. This becomes 5R. 2R plus R, 5R by 2. And this becomes 2 to cancel out, and 2 to 4, 2 to 4 plus 5, right? So this becomes R by 2R by 5. This becomes 2R by 5 for this. So 2R by 5 and R by 2 becomes R. So this becomes plus R, and this is R. This is A, this is B, this is R, this is A, this is B. So R equivalent would be, so this becomes 2R by 2, 5 to 7, 7R by 2, 7R by 5, 5 to 7, and R. So this becomes 7R by 2, 7R by 5, not 2. 7R by 5, so R equivalent, that is AB, R across AB would be 7R by 5 cross R upon 7R by 5 plus R. So this becomes 7R by 5 upon 12R by 5 R square. 5 5 cancel out. So this becomes 7R by 12. So we write here the equivalent resistance across AB would be 7R by 12 and its C equivalent would be 12C by 7. Similarly, for the phase diagonal, the equivalent capacitance would be 4C by 3. So here we discuss the three situations, the equivalent resistance across the phase diagonal, body diagonal, and its edge. So these topics eventually asked in JEE Mains in 2024 questions here. So by the concept, we can easily calculate out the circuit analysis. So I hope you better understand this topic, and thanks for watching this video. Thank you.